Good morning. Today we're going to be working problem 9 off exam 1 review spring 2009. We're asked to sketch a graph with the following properties, A through K. And the first property, we're going to make little notations on the graph here of each property, and then when we're finished, when we've moved through all the way through K, we're going to go back and connect all the dots with a curve that represents all these properties. So property A says the limit as x tends to limit as x goes to positive infinity of f of x is positive 1. So that tells me that as x goes to, the graph goes to positive infinity, we have a horizontal asymptote of y equals 1. So we'll just put that on the graph here, and we'll see how good it ends up being. So I'm just going to write my horizontal asymptotes in blue. So here I have this. We're technically only going to positive infinity with this, but I like to go ahead and draw my horizontal asymptotes all the way across. So we have that. And then property B says the limit as x goes to negative infinity of f of x, and it kind of doesn't look like an f there, of f of x is negative 3. So we have, as we go to negative infinity, this graph tends to y equals negative 3. So we'll put that on there. And so we have another horizontal asymptote down here. Now, of course, you know, this is only as it goes to negative infinity, and we're going to make a little notation of that to help us remember on the graph, and we'll do that in blue. As we go to positive infinity, we know that we're going to positive 1, so I'm just going to put that right there. And as we go to negative infinity, we go to negative 3, so I'm going to put that little arrow right there to signify when we put that graph in there that which way we're going. And we really don't know, and it probably isn't really going to matter which side I just happen to, which top or bottom of that horizontal asymptote it's going to approach it. I just put it on there. It's not really going to make much difference in this. So now we have, we look at the limit. Property C says the limit as x goes to negative 1 from the left of f of x is positive infinity. So I have a vertical asymptote at x equals negative 1, at least from one side. And I'm going to go ahead and look at D at the same time. And it says the limit as x goes to negative 1 from the right of f of x is negative infinity. So I actually have a vertical asymptote at x equals negative 1 from both sides. And it's approaching infinity from a different direction. We'll just go ahead and put that in here, though. I'll put it in here in red. And I will just, make this a little longer. Continue it out. And we'll make a little notation here as we come in from the left. This graph is going to positive infinity, and as we come in from the right of negative 1, we're going to negative infinity. So I'm just drawing these little arrows right here, positive infinity, negative infinity. And then we go to the next property, which is as x goes to 3, f of x is 4. Well, trying to decide what color to use. I'm going to use green. That means that the y values tend to the value positive 4 as we come in to the x value 3. So that's 1, 2, 3. 1, 2, 3, 4. So, and I caution you about putting a dot right there. Notice how I drew a circle. Remember, the limit as we come, the limits doesn't tell us what's going on at a particular value of x. It tells us what's happening around what the y values are happening around that particular value of x. So we may end up filling in that circle, we may not, but we know around there that the y values are tending to 4. So I'm going to go to the next property. The limit as x goes to 1 from the right, I mean from the left is property F, from the left is 1. Excuse me. So I'm going to put that property in there, and I think I'm going to use purple. So again, I'm not going to put a dot because these are just limits. I'm going to draw a circle. So as we come in from 1 from the left, we have a 1, so I'm going to draw a little circle right there. And then when we come in from 1 on property G, when we come in to 1 from the right, we have the limit of -4. So 1, 2, 3, 4. I'll draw another little circle. I'm not going to fill those in. Not yet anyway. We don't have enough information. The next property says f of 0 is 2. This says the value of x excuse me, at x equals 0 is 2. So that's a point. We'll go ahead and put that on there. That is a point. F of 0 is 2 is a point. Same thing with property I. F of -2 is -6. That is a point. So I'll go to -2, and then 1, 2, 3, 4, 5, 6, and hopefully that's. So I'll draw that point right there. That is a point on the graph. Now I look at the domain and the continuity. I'm going to kind of look at them together. I'm going to look at continuity first. F is continuous from -infinity to -1. Well, we could kind of expect that. We have a vertical asymptote there. Although when we have these properties, we're not guaranteed something like that, but it could be expected. Union -1 to 1, and then 1 to 3, and then 3 to +infinity. And then when I look at my domain, I notice that my domain is x is in the set of all real numbers except the values -1 and -3. So that means at every x value except -1 and +3 on this graph, there is a y value associated with it. And so at -1, as we discussed, that's a vertical asymptote, so we won't fill in a dot there. Although you can have a vertical asymptote and something in your domain tells you to fill in a dot there, but in this case we're not. And then at 3, we're not going to, so this hole right here I drew at 3, 4, we're not going to fill in. But notice here where we have this little jump in the graph, one of these little dots needs to be filled in because +1 is in the domain, so therefore f is defined at +1 even though it's not continuous at +1. So we're just going to connect the dots, and I'm just going to use the color black. And I know that as I come in here from -infinity, I've approached the value of -3. I know it's got to come down here and hit this point, and then I know it's got to shoot up to +infinity because of what property C told me. And then on the other side of -1, we're coming in from -infinity, coming up or whatever. We come up, and we know we definitely have that point 0, 2 on the graph, and then we come down to 1, 1, where that circle is. You can fill that one in, or you can fill this one in. I guess I'll just go ahead and fill the point 1, 1 because it's defined. But if you fill this one in, definitely don't fill this one in. So I pick up back at point -2, or no, I'm sorry, 1, -4, which the limit told me, and that's going to remain open because I've already filled in the point 1, 1, and I'm going to bring the graph up to that hole. Not going to fill it in, and then just to complete the graph, it's going to have to do something at some point. I mean, this is not a unique graph other than it presents all those properties. It's going to come down there, and as it goes to +infinity, it's going to approach that horizontal asymptote of y equals 1.